Welcome to The Explainer. Okay, we have a huge problem to solve. How are we going to feed billions more people in the very near future? I mean, our farmland is already stretched to the absolute limit. So, where do we go from here? Well, what if I told you the most promising answer isn't on land at all? All right, before we get to solutions, let's really wrap our heads around the scale of this problem. The numbers we're about to look at are, well, they're pretty staggering, and they set the stage for everything 70%. Just let that number sink in for a second. 70%. That's the estimated increase in global food we're going to need by the year 2050. That is a colossal jump in what is really not that much time. Okay, and this is where things get complicated. 50%. That's how much of the Earth's livable land we are already using for farming. So you see the problem, right? If we need 70% more food, where on Earth is that land supposed to come from? And that's the real heart of the issue, isn't it? We can't just chop down more forests. We absolutely need them to help fight climate change. So the only real option is to get a whole lot smarter with the space we already have. And that brings us to a really popular, super high-tech concept you've probably heard about. Yeah, for a lot of people, this is what the future of farming looks like. These slick indoor warehouses with crops stacked from floor to ceiling, glowing under purple LED lights, everything managed with incredible efficiency. It's a vision that's really captured a lot of imaginations and, as it turns out, a whole lot of cash. And believe me, this is not some little niche idea. We're talking about serious, serious money pouring into this space. I mean, just look at a company like AeroFarms. They've pulled in nearly $250 million in funding. When you see numbers like that, you know investors are betting big. And you can see why they're so excited. I mean, on paper, the upsides are just incredible. We're talking up to 15 harvests a year. It runs 24/7 all year round. It uses practically no water, no nasty chemicals or pesticides. It doesn't even need dirt. You can grow stuff vertically, horizontally. It's like they took all the problems with traditional farming and just solved them. But you know how it goes. With any amazing new tech, there's always a catch. And when you start to dig a little deeper into the vertical farming dream, you find a pretty significant one. It's something we really, really need to talk about. So, the first big issue, the cost. It is just astronomically expensive to build one of these things. We're talking $2, maybe $3,000 per square meter for a fully automated farm. Now, sure, they can crank out 100 times more crops in the same space, but that initial price tag, that's a massive wall for most people to climb. But honestly, that's not even the biggest problem, not by a long shot. Here's the real deal breaker. Vertical farms are fantastic for things like lettuce and herbs, but for the staple crops that actually feed the planet, wheat, corn, rice, the things that take up most of our farmland, they are massively inefficient. The math just doesn't add up. And that right there gets us to the bottom line. If these farms can't grow the grains and cereals that cover millions of acres of our planet, then they can't help us free up that land. And if we can't free up that land, we can't replant the forests we so desperately need. So vertical farms, they're a solution for sure, but they're a solution to a much, much smaller problem than the one we're trying to solve. Okay, so if stacking farms higher and higher on land isn't going to solve our biggest land problem, then what will? Well, this is where we have to make a radical shift in our thinking. It means leaving the land behind entirely and heading for the ocean. That's right. The real next-gen farming might not be happening in some sterile high-tech lab. It might be happening out in the water. It's a concept called 3D underwater farming, and honestly, it has the potential to be a total game changer. So what exactly is 3D underwater farming? Well, the idea is so simple, it's brilliant. Instead of building all this expensive infrastructure, you just use the ocean itself. You use the entire water column, from the surface to the seafloor, to grow different things all together. It creates this amazing, self-sustaining little ecosystem, and it's all built around one powerhouse plant. Let me walk you through it. So you've got these long lines near the surface where seaweed just soaks up the sun. Then, hanging down below the seaweed, you have ropes where mussels grow. And then way down on the seafloor, you have cages for oysters. The whole thing works together. It's a complete ecosystem that's basically a zero-maintenance, zero-input farm. It just works. Okay, we have to talk about seaweed, because seaweed is the absolute heart of this entire system. So what is it that makes this, humble sea plant such a planetary superhero? Trust me, it does way, way more than you think. Let's just start with the really big picture, okay? All algae, and that includes seaweed, is responsible for producing up to 90% of the oxygen we breathe. 90%! And it makes up about 80% of all the organic matter on the entire planet. The scale of its impact it's just hard to even comprehend. And check this out. When you look at capturing carbon from the atmosphere, it's not even a competition. Seaweed is an absolute monster. It can pull in up to 14 times more carbon per square meter than plants on land can. Seriously, growing more of this stuff is one of the most powerful tools we have in the fight against climate change.
But wait, there's more. Its superpowers do not stop there. It's a superfood for us, with 10 times the minerals of land plants. You can turn it into sustainable biofuel for planes and ships. You can use it as fertilizer. It's used in medicine, in cosmetics. I mean, the list of what you can do with this stuff just goes on and on.
And this isn't some futuristic pipe dream either. This is happening now. Researchers in Denmark actually took a regular car, filled it up with a seaweed-based biofuel blend, and it ran perfectly. No difference in performance. That proves it. A sustainable fuel source that doesn't take up valuable farmland, it's not just possible, it's already here. You know, maybe the most exciting part of all of this, though, is just how simple and accessible it is. When you compare it to the super high-tech, expensive alternatives, this is a whole different ballgame. This is not a solution that's just for giant corporations. Get this, $20,000. That's about what it costs to get a 20-acre underwater farm up and running. $20,000. Now remember those vertical farms? We were talking millions. This is a tiny, tiny fraction of that cost. So what this really means is that we're looking at a solution that tackles food, fuel, and climate change all at once. It's a farm that basically runs itself, it's easy to get started, and it's something that almost anyone, anywhere with access to the water can actually do. Which kind of leaves us with one big final question, doesn't it? If we have a solution that's this powerful, this affordable, and this good for the planet, a solution that's already here, then what are we waiting for?